This question is asking you to find the y to the power of 4 term in this expansion, and here the expansion is to the power of 5. So if we were to look at the fifth row of Pascal's triangle, it looks like this: 1, 5, 10, 10, 5, 1. Now you might say, well, I'm never going to remember that, so how on earth am I going to do it? Well, you remember you can actually use your calculator to generate any row in Pascal's triangle. We're going to generate a list. So you go to your y is equal to, and the first thing you to do is to enter the row number. That's the first thing you do, and your row number is 5. The next thing you do is to go to this label here, maths, and then once you click maths, look for this sign here, which is PRB, which stands for probability, and then go to this figure here, number 3, which is NCR, and this is means combination. Okay, we're looking at the combination formula. N choose R. Then you enter X. Use this X here because that's your variable, and that's how we're going to generate the table. Once you've done that, you click on second, and then you want this table, and this is your table, and there is your fifth row: 1, 5, 10, 10, 5, 1. Now don't forget this feature because this can be very, very handy. Going back to the question, if we were to consider a plus b to the power of 5, you may remember the pattern was that this would be a to the power of 5, the first term. The second term is going to be 5a to the power of 4b. The third term is going to be 10a to the power of 3b squared, and then 10a to the power of 2b cubed plus 5a b to the power of 4 plus b to the power of 5. And that's the pattern, and of course we're using these as our coefficients from the Pascal's triangle fifth row. The question is asking us to find this term, the term where your a is going to be to the power of 4. So in order to find that term, we know that the coefficient is going to be 5, and then a, in this case, is 4y to the power of 4, and b, which is -1, okay, to the power of 1. Remember, the powers always add up to whatever the initial was, which was 5. Now it's a matter of remembering your exponent rules. So we got 5. Now remember that this power has to apply to everything inside the bracket. So it's going to be 4 to the power of 4 and y to the power of 4. And then of course your b, which in this case is -1. So now we can finish that off. We've got 5, 4 to the power of 4, use your calculator, it's 256, y to the power of 4, -1. So this -1 is going to affect this by this. It's going to be, the whole thing is going to be negative. So 256 times 5 is 1280 y 4. Now that is the y to the 4 power. So that's how you can find it. Now there is another way you can find it without having to use, without having to go to your calculator to find this, and I'll explain this now. The pattern of Pascal's triangle is made up of this binomial coefficients, and these binomial coefficients are n choose r, and that means n factorial over r factorial n minus r factorial. Now that all looks very complicated, but you can just enter that into your calculator the way I said it before. Now every part of Pascal's triangle is made up of these binomial coefficients. Now I tried to explain to you before what this actually means in terms of probability, and this is the number of ways you can arrange n objects. And altogether, n choose r is the number of ways you can choose r objects from n. So just to remind you what that means, say for example you've got a box with different colored balls in it. Say you've got 5 balls in here and they're all very different, and you want to know how many ways can you choose 2 balls. Okay, so from 5, so that would be 5 choose 2, and you can put that into your calculator the way I showed you, or if you wanted to calculate it by hand, this would be 5 factorial over 2 factorial times 3 factorial. Right, so it's 5 times 4 times 3 times 2 times 1 all over 2 times 1 times 3 times 2 times 1. Okay, and that equals 10. So you can do that either way. So that's what that actually means. But what's fascinating is that Pascal's triangle is made up of all of these binomial coefficients, or what make up Pascal's triangle. So if I was to draw that in terms of binomial coefficients, this is what it's going to look like overall. So here I've got the Pascal's triangle filled in with the binomial expressions up to the 5th row, which is what we were talking about before, because remember, originally we were trying to find the 5th row. Now that coincides with the expressions. Remember that this coefficient was 1, and this was 5. This is 10, 10, 5, 1. And that coincided with the fact that we have our a to the power of 5 plus 5a to the power of 4b plus etc. And this is the one that we're interested in. But look here, we can use this. Okay, that's our coefficient, right? So if I do 5 choose 1, A for B, I can simplify, but what's interesting is that it's exactly the same as this. 5 choose 4 is the same as 5 choose 1. How does that work? Well, look, 5 choose 4 is 5 factorial over 4 factorial times 1 factorial. And 5 choose 1 is 5 factorial over 1 factorial times 4 factorial. So they're the same. So in actual fact, I can use the coefficient. If I'm looking for the 4th power in the 5th row, then I simply say 5 choose 4. Okay, it's exactly the same. So rather than generate the whole row with a list in my calculator, I can simply enter 5 choose 4 directly into my calculator to get that coefficient, instead of generating a whole table. And this is how I do it. I first enter 5 into the calculator, and then I go to this symbol here, math, and then I go to probability, PRB, and choose this one here, NCR, and then I press enter, and then I put in 4, and the answer that it'll give me will be 5, because 5 choose 4 is equal to 5. So it's 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 and 1. It's 5. So I don't need to generate a list. I can just go straight to that term. So going back to the question, what is the y4? I went directly to, okay, I need 5, choose 4. I need this to the power of 4, and don't forget the b, and that will be exactly what I had before. 5, 4 to the power of 4, y to the power of 4, negative 1. Remember, just remind you again, you've got to do the powers there. Remember your exponent rules. And then you end up with the same answer we had before, which was 5 times 4 to the power of 4 is 256. Y to the power of 4 times negative 1. So bring that negative 1 in front. Negative, what's 256 times 5? 1280. Y to the power of 4. Let's just consolidate that by saying, I want you to tell me what is the y cubed term going to be. So this time I'm just going to go directly and say, well, I've fifth row, 5, choose 3, and then your a, 3, and your b is this time 2. Remember, they have to add up to 5. So let's put this in, 4y cubed negative 1 squared. Now what is 5 choose 3? Put that into your calculator if you like, or I'm just going to work it out by itself. 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. Remember that this is 5 factorial over 3 factorial times 2 factorial. Okay? Remember this, going back to this, n minus r. So this is just equal to 5 times 4 over 2 times 1, which is 10. So 10, 4 cubed, y cubed, negative 1 squared. So this is just going to be equal to 1. So 10 times 4 cubed, which is 64, times y cubed. So this is going to be 640 y cubed. That is the y cubed term when I expand this. There I just did it very much the shortcut way. So now let's look at the next question, which is asking you for this term in the expansion of this. So the row that we're interested in is 6. So I'm just going to go straight away and say, I want 6, choose 2, a squared, b 4. And then I'm going to substitute in this a into there, and this b into there. So 6 choose 2. Now my a squared is going to be 2a. Now remember to square the whole thing. And my b to the power of 4 is negative 3b to the power of 4. Do not forget that you have to use that entire b. Use it together with the negative. Now just another reminder that whatever your exponent rules say, that you need to power up everything inside of there. Okay? So let's not worry about 6 choose 2 just yet, because we can let our calculator do that if you like, or we can work it out by hand, whichever you prefer. But let's carry on. 2 squared, a squared. Now, I strongly advise you to do all these little steps and not skip them, because should you make a calculation error, you'll still get marks all the way through these steps. So you might just lose 1 mark if you make an error in your calculation, but if you don't put the steps in, then the examiner's not going to be able to invent marks. Right, so let's find out what 6 choose 2 is. I can do it on the calculator or by hand. If I do it on the calculator, I need to enter it like that in the same way that I showed you before. If I do it by hand, I'm just going to go 6 factorial over 2 factorial times 4 factorial. Now I know that I can just cross out this 4. See, if I go 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, this 4 factorial underneath is going to cancel itself out. So really I've just got this left. And that's not so difficult because I just put that into 3. So the answer is 15. If you remember your 6th row of Pascal's triangle, or if you look it up, you'll see that it's 15. So that's already got me a lot closer. 15. Now, 2 squared is 4. A squared. Now, negative 3 to the power of 4 is going to be positive now. Negative 3 to the power of 4, that's 81. B to the power of 4. Now I can just multiply these numbers in my calculator. So that's 15 times 4 times 81. And I end up with 4860 A squared B4. And that is the answer. So you see, that wasn't too difficult because I just went straight to this step. Now remember what I said before, 6 choose 2 is the same as 6 choose 4. So you could have said 6 choose 4 and you would have had the exact same answer. Okay, because 6 choose 4 is the same as 6 choose 2 when you calculate it out. Okay, and that's your answer. So hopefully that's given you an overview so you can keep going now.